With today's great advances in technology, if a person needs to defrost a frozen item, with access to a microwave, they can just set it on defrost. But what if they didn't have a microwave or any other type of heating instrument? How could they defrost the item in the least amount of time? I came up with a hypothesis based on my theory that if the surface the ice was sitting on had a lower specific heat capacity, then the surface would reach a higher temperature. Then, since the surface's temperature was higher, the surface would transfer more heat to reach a thermal equilibrium with the ice at a rapid rate, thus melting the ice quickly. I tested my hypothesis by placing ice cubes on wood, modeling clay, granite, and paper. By placing each ice cube on a surface with its own specific heat capacity and by comparing them side by side during the experiment, I could easily tell which surface the ice took the longest time to melt on. You can see at the beginning of the experiment, each ice cube is the same shape and size. But as you can see in this photo, taken 1 hour and 41 minutes later, it's obvious they are not all melting at the same rate. Taking note of which order they melted in was critical to prove if placing the ice cube on a surface with a lower or higher specific heat capacity could indeed make a difference in how long it took for the ices to melt. They melted in this order: granite, modeling clay, wood, and paper, which happened to be the same order in which specific heat capacities of the surfaces ranged from lowest to highest, providing support for my hypothesis, which lets people know if you put the ice on a surface with a low specific heat capacity, it will melt in the least amount of time.